Hi, this is 5.3 in your textbooks. Once again, we are talking about slope, very important concept in grade 9. Hopefully, today again will be much of a review for most of you guys. The goal is to determine the slope of a line. We've done this several times now. Example 1 says calculate the slope of a line passing through points 5, 3, and 7, negative 4. Some of you might have done this on the worksheet a couple days ago, but I haven't done a lesson exactly on it when you're given 2 points. So that's what we're doing today. So again, there's always 3 ways to do this. My preferred way, of course, is the equation, which I think most of you guys should probably also prefer. But we're going to start with the table of values. We know the x values are the first coordinate number in the point. So I list them there, 5 and 7. And then our y values are 3 and negative 4. So I made a quick table of values. And then to get the slope, you just minus 2 points that are in succession. So negative 4 minus 3 will give us the rise. And then the run will be 7 minus 5. Okay, so negative 4 minus 3 and 7 minus 5, there's our slope. Okay? Yeah?
Does it matter if you do a 5 minus 7, 3 minus negative 4?
It actually doesn't matter as long as you're consistent. But yeah, they give the equation. You're going to see in a minute. I wouldn't use this. I'm just showing this to be consistent with the other lessons. Okay? I don't think the book even shows this. I just thought I would be, staying consistent. The graph, of course, we would plot these 2 points. So point A is over here, and point B is down here. And then what we would do is we would measure, count on the graph, just physically count the rise. In this case, it's a lowering, so the rise is negative 7, and then you count the run, which is 2. So between these 2 points is 2. Okay, and of course, if your graph was much more accurate, that would be something realistic that you could do. Again, the easiest and the most preferred is the equation. Okay, we know this formula now. M equals y2 minus y1 over x2 minus x1. This is the formula for rise over run. Okay, so I'm just taking y2, which is right here, minusing y1 here, and then x2 minus x1. So I end up with that exact same slope, negative 7 over 2. Any questions? Okay, pretty simple, pretty much a review of what we already know. Example number 2, it says determine the value of k using the graph. So we have 2 points here. Very important to note out that our slope is given, okay? Without that, we couldn't find the point of k, okay? Because we wouldn't know how much it's rising for the distance that it's running, okay? So tell us our slope is 1/2. So that means if we know this point is negative 1, obviously if this was a well drawn out graph, you could just measure and see what the value of k is. It's the y value here, right? So this is k right up here. So you could literally just count it off, okay? Another way you can use it using the graph is if we know the slope, right? If it's 1 over 2, so that means we're rising for every 2 that we run. So if we're at negative 1, we're going to rise up 1 and run 2. So changes from negative 1, the run is going to change 2 points, and the rise is going to change 1 point. All right, so we're going to change the run 2, so this becomes positive 1 as it rises 1. So it would be 0, this would be 0, 1, 0. Okay, the next point, you're going to rise 1 and run 2. 1, 2, so it would be 3, 1. Next point, you're going to rise up 1 and run 2, 1, 2. So this would be 5, 2, rise 1, run 2. This point would be 7, 3, rise 1, run 2. This point would be 9, 4. Okay, everyone understand that? I used the slope, I went from the first known point and I just rose up. Another way, obviously, if the graph is graphed, as I said, very accurately, you could just look for k there. Okay?
Sure.
And then finally, using an equation, yeah.
Are we going to have to know how to graph it, or can we just do the equation?
You have to know how to graph it.
Or like,
Do have
You
to
know how to
go
graph
find-
it, right?
No. Do we have to go and find K on a graph?
Yes.
Oh, okay.
I just explained it though, right?
Yeah,
You can
yeah.
either just look at the graph, or you can go with the slope. Number 2, with an equation. This is much easier, right? We're just gonna substitute our values in now. So we know what y2 is, in this case, we don't know y2, it's k, minus y1 is negative 1, over x2, which is negative 1, minus, x2, which is 9, minus negative 1. Okay, that's all the values we've set there, and that's equal to a half. How do I know it's a half?
Slope.
Yeah.
As a slope.
Yeah, it's given, the slope, yeah. Okay, so now let's just work this out. We have k plus 1 over 10 equals 1/2. So k plus 1 is equal to multiplying both sides by 10. The 10 on this side cancels. So I'm going to have this multiplied by 10. Right, these cancel. I'm going to have 10 divided by 2, which is 5. K is equal to 4. Alright, same answer. Any questions there?
Sir, how is it? 4?
It says plus 1.
You move it over.
The 1 comes over, becomes
Oh.
5 minus 1.
Okay.
Okay? Alright. Example 3 is a word problem, but it's very much of the same. It says the bathtub is filling with water at a constant rate. So a constant rate, that's got to trigger something. If it's a constant rate, that means we're talking about a straight line. Okay, that's what all these graphs are. It's constantly increasing at the same rate, right? If it's a straight line. If it's not a straight line, then the rate at which it's increasing is changing. If it's a constant rate, it's a straight line. After 3 minutes, the water is 7.5 centimeters deep. After 8 minutes, the water is 15 centimeters deep. At what rate is the depth of water increasing? See, so this is a real-world experiment that you guys can do at home. You want to know when your bath is ready, you can measure it at 1 minute, then measure it again at 2 minutes, and assuming that the water pressure in your house stays constant, you can know exactly when your bathtub is going to be full. Okay, so very practical. Yeah,
I was wondering, how would you solve an equation that's like not constant, like data is
grade
not
10.
constant? Pardon?
Grade 10. Yeah.
Is it 8 centimeters deep or 15?
It is, I think it's 8 minutes, it's 15, thank you. Daniel missed that again, eh? Daniel's slacking, because he doesn't copy the notes down, that's the problem. All right, it says at what rate is the depth of water increasing? So what is it asking for, really? In terms of graphing and everything else, what's it asking for, Matthew? Yeah, it's asking for the slope. We visualize this, right? What am I going to put on the x-axis? Yeah, Joseph.
Minutes.
Sorry?
Minutes.
Right, the minutes, so time, good, time in minutes. And then Nicholas over here, what am I going to put on the y-axis? Where is he? Nicholas?
The water pressure?
No, water pressure.
Centimeters.
Yeah, what is that centimeters though? It's the water,
Rise.
yeah, the water depth, right? Water depth in centimeters. So what they're asking for us now, what is the rate at which the water's rising? They're asking us for the slope of this particular graph, okay? So Michael, right there, what's the equation for a slope?
Delta y over delta x.
Okay, one way to say it, yeah, delta y over delta x, which is what?
Y2 take away y1 over x2 take away x1.
Which is what? So be careful now. T is down here, Michael. So T is actually the x values, right? So you don't want T on the top.
7.5 take
Good.
away 15
Nice, very good, yeah. Over?
over 3 take away 8.
Excellent. Very good, Michael. All right, now we can just go ahead and solve for this. So 7.5 minus 15 is negative 7.5, and 3 minus 8 is negative 5. So we're left with 7.5 over 5. We can't have a decimal in a fraction. That's improper. It goes,
Can't you just read that if you look at the problem? You do like,
yeah, you
Can
can,
I-
Can it be
Minus
75
yeah.
over 50?
but you have to be able to do it this way to get marks, okay? Sorry?
Can it be 75 over 50?
Yeah, you could do that, it's one way. It's a little bit long, but yeah, 75 over 50, now I gotta reduce this, right? Michael?
So can it be 1.5? I mean, just, yeah, 1.5.
1.5?
Yeah.
Yeah, you're right. It is 1.5. Good. 1.5, because he sees that, right? This ends up being divided by 5. This is 10. Divided by 5, this is 15. And this is 3 over 2. Okay, yeah.
What did the, 15
Stop it there.